All right. This section is all about patterns, equations, and graphs. So this one might take a little bit more time to do. You might have to pause it, rewind it, go back and take a look at it again. But looking at this first one, it says identifying solutions of a two-variable equation. What they mean by two-variable equation right here is means that you have an x and you have a y. Okay, so that's what they mean by a two-variable equation. Okay, so how do we do this then? It says, is 3 comma 10 a solution of the equation? Oh, I don't know what that 3 comma 10 is, but I'll tell you right now. 3 comma 10 is an x comma a y. It is a point. Okay, it is actually a point. So what I'm going to do is I'm going to try to plug this in. Wherever I see the letter y, I'm going to put the number 10. And wherever I see the letter x, I'm going to put the number 3. Okay, wherever I see the letter X, I'm going to put the number 3. So what I get is, I get 10. Is 10 equal to 12? No, it is not. So that means that it is not a solution to this problem. Okay, so it is not a solution. So what you have is a got it. Why don't you pause the video and try it? I'll see you back here in about a minute. All right, problem 2. It says using a table, equation, and a graph. So both Carrie and her sister Kim were born on October 25th, but Kim was born 2 years before Carrie. How can you represent the relationship between Carrie's age and Kim's age in different ways? I don't know. I guess we could probably do something like with a table. And if I did like a table, I'm going to put Carrie and Kim, right? So Carrie and her sister were born on the same day, but Kim was born 2 years before Carrie. So how can you represent this relationship between Carrie's age and Kim's age? All right. So if Carrie is 1, how old is Kim? Well, she's going to be 3, right? If Carrie is 2, Kim is going to be 4. If Carrie is 3, Kim is going to be 5. If Carrie is 6, Kim is going to be 8. Is right? It makes sense. If she is 4, Carrie is going to be 6. If she is 7, Kim's going to be 9. You get the idea, right? You could do that. That's one way to do it. You could come up with an equation. If I call Carrie's the X and I make Kim the Y, then how do I get Kim's age? I take whatever Carrie's age is and I add it to 2, right? So there's a table and there's an equation. I could even graph this if I wanted to. I could even graph this. Check it out. I could graph this. What I could do is I could put in the point. I could put in the point 1 comma 3. So 1 3 and put a dot there. I could put in a point 2 comma 4 and put a dot there, right? I could probably go 3 comma 5 and put a dot there, right? And then you can see that that is a line that represents their family. All right. So I don't think you necessarily, hey, you don't have a smart board, but you could do this real quick on the side there with a straight edge or something real quick. All right. So you have a got it. Why don't you take a minute, pause the video, and try to do the got it. I'll see you back here probably in like 3 minutes. All right. Here's one, extending the pattern. It gives us a table. So the table shows the relationship between the number of blue tiles and the total number of tiles in each figure. Extend the pattern. What is the total number of tiles in a figure with 8 blue tiles? I don't know, right? I absolutely do not know. So what I could do is I can look at this and I see I got 1 and 9 and 2 and 18 and then 3 and 27, 4 and 36, 5 and 45, and then I got these pictures. But for me, I look at this table and I'm looking at, whoa, it's moving around a little bit. I'm looking at this stuff. There is a pattern. How do I get Y? What's the relationship between the X and the Y? How does 1 become a 9? How does 2 become an 18? It looks like it becomes by doing 9 times x. So by using my equation, 9 times x, I can actually figure out, it says, what is the total number of tiles if you have a figure with 8? Well, then I'm going to go ahead and I'm going to plug in 8 for x. 9 times 8, y is 72. So I would need 72 total tiles to do that with 8 to make it look right. So that's what I used. I made a table. Now the table came about because they had one blue. See, there's the one blue table or one blue tile and a total tile of 1, 2, 3, 4, 5, 6, 7, 8, 9. Right? And then here's 2 blue tiles, and then they counted out the total number of tiles. So they made a table like that. You have a got it. Pause the video, make a table, see if you can do it. All right? I'll see you back here in just a couple minutes. How'd that go? I bet you it was probably pretty much a nightmare because it's pretty tough. But we'll talk more about it in class because this last section is pretty detailed and pretty challenging, especially if you've never seen it before. But what you do have here is you have solution of an equation. If you know what that is, cool. If not, put it in your words to know. We have inductive reasoning. We don't know what that is, so I would look that up, and I'm not even going to check it because I'm going to put that in my words to know. And then I'm going to actually rate myself. How well can I identify solutions of a two-variable equation? So that finishes section 1-9. I hope that it helps. If you need to, watch it again, and I'll see you tomorrow in class. And may the force be